6.9. What is, how do I find perimeter? Yep, and what's the length of the hexagon? Which would be here, right, because this is all going around like this. So it'd be 8 times 6, which is 48. And so the formula is 0.5 times 6.9 times 48. But how many of these do I have? I have two of them. So I'm also going to be multiplying this by 2. So if you could put that in your calculator and give me the answer, that'd be wonderful. 331.2. Can someone else verify that? Did someone else get that answer? You were the only one who got it? Right? Not that I don't trust you, but I make mistakes too, so I like to get a verify. Oh, there you go. We got another verify. Okay. And now, so this is the bases, right? This is the bases. And now I need going around the outside. I have 6 congruent rectangles. What are the length and the width of these rectangles? Yep, it's a 6 by 8, and I have 6 of them, so it's going to be 6 times 8, which is equal to 288. And then you want to add these two together, and that 619.2, and that would be meters squared, and this is surface area. Please be careful on the test to use the correct formulas. Remember, in the directions, this one says surface area, and down here it says volume. I do let them use their notes for their tests, and the reason is just we're cramming so much into their brains in 8 weeks. Yeah, exactly. So I do let them use their notes. What about here? I have a cone, and so volume of a cone is 1/3 area of the base times the height. What? Well, no. Well, the area of the base is, I'm talking and doing this at the same time, so sorry. Area of the base is your pi r squared. So volume is 1/3 pi r squared h. What's r? Ignore this. Ignore this. Um, well, technically, this is still true, right? Because the area of a circle is pi r squared. I just haven't written it like that before. I usually write down this formula. So radius is 5. What's the height? 11. So 1/3 times pi times 5 squared times 11, right? And in the calculator, you could just divide by 3 for that 1/3, or you could put a 1/3. So 87.98, and it does say to the hundredths on this one. And that would be miles. Boy, that's a weird cone for miles. Miles cubed. What? 287? I missed the 2. There. Sorry. Remember, I'm old. My hearing and my eyes are going. You guys got to be loud for me or check my work. Questions? Remember, this is volume. This is the volume for this one would just be area of the base times the height. So it's capital BH. The area of the base would be this regular pentagon. So I would do the formula for a regular figure. That's 0.5 times, what's my apothem? 8.3 times perimeter. Perimeter is equal to 12 times 5, because I have 5 sides going around here. So 12 times 5 is 60. So go ahead and give me, it's here. I was just talking about that. And I'm going to have to figure out how to get it put together. Oh my. My husband may be visiting on the weekend. What's 0.5 times 8.3 times 60? 249. And now what's the height, which is the distance between the two bases, is 8. So volume is going to equal 249 times 8, which is, and that would be feet cubed. What type of shape is number 5? It's a pyramid. What's the base? Triangle. So when you have a pyramid, it's the volume equals 1/3 capital B, which means area of the base, not the base of the triangle, which is small b. I know it gets confusing, times the height. So the capital B, I'm going to scroll this up, is a triangle, which the area of a triangle is base times height divided by 2, or 1/2 base times height. This is your base, right? Now on right triangles, and we know it's right because it has a 90-degree angle mark right here, the legs are your base and height. So what's your base and height? 8 times 6. 8 times 6 divided by 2. And this is capital B. This is the area of what it's sitting on. So that would equal what, 24? Is this the same one from yesterday that I didn't change it? I think it is. I think it is. I think I changed all the other ones, but I don't know. It's been a hectic morning. I'm so sorry. Okay, so H is, what's your height? 11. So it's 1/3 times 24 times 11, which should give you a volume of what? 88 kilometers cubed. And I'm going to hand these out so you can do the open end. This one is on the test just to verify you know your vocabulary. You need someday. Okay. Uh, that was about credit utilization. Y'all should take my financial foundations class. Econ, but I think you said you already took it. But you also get 2 business math. It's 4 credits. 2. I know, especially with me. I know. Okay, so in the directions going back, it said draw a circle. And what am I labeling the center as? So I'm labeling the center as C. You actually have on those little templates, believe it or not, this thing here marks the center of your circles. Line this up on one of these circles. This actually finds the exact center, if you didn't know that already. Okay, so then please read because I'm not on my page. What do I have to draw next? A radius. And label it AC. So a radius, I have endpoints on the circle, right? So I'm going to put a point here, and I'm going to go ahead and put an A, and then draw my line, right? I'm going to change my color just so you can see. What's the next one? Diameter. And what am I labeling the diameter? BD. How many diameters are there in a circle? There we go. You've learned something. Okay, so as long as it's going through the center, right, I could do it like this. And then this would be BD. Okay, now what am I drawing? A secant. What does a secant do? Cuts through the circle. So it intersects the circle in two different spots, right? And it's a line that intersects the circle. Oh, I didn't use my line tool. Use your straight edge. Don't be squiggly like me. Okay. What am I supposed to label this as? E, F. And then what was my last one? Tangent. And a tangent only touches the circle at one point. We learned a lot of theorems on tangents, that if I drew a radius from this point of tangency to C, it's going to be 90 degrees, right? And then if I have any chords on the inside, if I draw it in as perpendicular, it cuts the chords in half. Remember all of that fun stuff? Okay, so, and then this would be my arrows. What was I supposed to label this one as? G, H. Are we done? I didn't have you draw a chord, but which one of these are a chord? B, what's the last letter on that? B what? B, D. Remember, a diameter is a special chord that goes through the center of the circle. It's also the longest chord in a circle. Okay, so I'm going to do this. Now find the length of the segment indicated. Round your answer to the nearest tenth if necessary. On the test, if you are confused about what pieces they're talking about, please let me know, because I know these are labeled kind of goofy. So this 6.8 is for this right here. You are looking for this X here. Do you know about all radii of a circle? They're the same length, right? They're congruent. So if this is 11.1 here, this is also 11.1 here. And also, this whole thing has to be what? 11.1. So how would I find this little piece if the whole thing is 11.1 and from here to the chord is 6.8? Just subtract. So 11.1 minus 6.8 is what? 4.3. And it doesn't have a unit, so I'm going to just put a U for units. Questions? Concerns? Test tomorrow? Yes? No. 11.1 is from here to here because it's a radius. See, all radii of circles have to be equal. Think about spokes on a bike, right? All those spokes have to be the same measure. Well, the same goes for any radii in a circle. So if I had a piece of it and I know that the whole thing is, to find the other little piece, I just subtract the two numbers. Got it? Okay, good. Okay, these are my favorite. It's Hal's favorite, but Hal's not here. Oh, Hal likes these. Okay, so we learned that if I have a point outside of a circle and I have tangent lines drawn, the point outside to that point of tangency is going to be equal on each side, right? So if I need to find perimeter, I need to find all these missing lengths. Well, if this side is 13, what's this side over here? 13. This little piece on the inside is 8.2 because this one's 8.2, right? So how would I find this length? 20.3 minus 8.2, which is equal to 12.1. And so now that I know this is 12.1, this outside piece is 12.1. Be careful, you only want to add the outside pieces. You don't want to accidentally double add a segment. So I'm going to do 12.1, 13, 13, 8.2, and 20.3. And that will give me the perimeter of that triangle. So we need to add 20.3, 8.2, 13, another 13. I could put point zeros if I want to line this up, and 12.1. I'm also going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I have them all. So what is this answer? 66 or 56? 66. And no units, so I'm just going to put a U for units, whatever the unit measure was. Okay. Find the length of the segment indicated. Round your answer to the nearest tenth if necessary. So on this one, we have an issue because I can't use oh, I'm the spotlight on our Facebook page this month. Hey. Sorry, if you're not part of our Facebook, join the Facebook. Right here, we know that this chord, if I draw from the radius and it's perpendicular, that it cuts this in half. Remember? So if this here is 16.4, what's this over here? 16.4. Now I have a right triangle. Do you all see a right triangle? And it's asking for this leg of the right triangle. What formula could I use on a right triangle to find a missing leg? Pythagorean theorem. A squared plus B squared is equal to C squared. A and B are the legs. C is your hypotenuse. I always tell you to figure out what C is first. So on this right triangle, what's going to be the hypotenuse? 19.4. Very good. 19.4 squared has to equal x squared plus 16.4 squared. So am I going to add after I square or am I going to subtract after I square? Subtract because they're on opposite sides of the equal sign. So if I do 19.4 squared, and I'm going to subtract the 16.4 squared, I get that x squared is equal to 107.4. Am I done? Good job. I've trained y'all well. What's my last step? Take the square root. You don't know how many students forget to do that. And I cry when I grade those tests and they forget to take the square root. Yeah, thank you. So that's 10.4. Again, no units, so I put a U. Do. How are we feeling on surface area, volume, and a little bit of circles so far? We're going to do well tomorrow on our tests. Our last test, if you're not taking the final exam, if you're choosing to do the project. For some of you, your last math test ever. Lakeith, ever. Yay! Yay! Okay, so find the measure of the arc or central angle indicated. Assume that lines appear to be diameters. our actual diameters. It's asking for angle UTV. UTV, right? And this means angle, while this means arc over here. Huh? Any ideas? 60 plus 61 is 121. And then what do I do? Oh, right? Okay. He'll explain in a second. Let's get the. Okay, but Nasala, can you explain for others who may not have gotten it? Why did you know all this? How did you know to do these steps? Well, I know, but they don't know how to do it, some of them. How do I know? What do I do? What do I know? I have a diameter, and what does a diameter do? Okay, so the diameter cut this into 180 and 180. So if I add these two together, subtract it from 180, that will give me this. Oh, sorry. Forgot to borrow 59, and then over here would be 59. Because central angles and the arc that it intercepts are the same, or subtends. Okay. Now it wants arc. Oh, IJ, you do the exact same thing. So this is IJ, right? You have this diameter. So if I add these two together and subtract it from 180, it gives me that missing arc. So 62, I should have made that one more challenging. And 180 minus 107, 73 degrees. Y'all are geniuses. You don't need me anymore. Hmm. Hmm. Find the measure of the arc or the angle indicated. So here's the question mark, right? Which, if I look at this inscribed angle, this is an inscribed angle, correct? It subtends, or I use that word cut, this arc over here. If I could find this arc, all I have to do is divide it by 2 and it equals this angle. We talked about that and you all did that. You drew central angles and inscribed angles and found that it's always half. So, how am I going to find this arc here? Subtract from 180, because look it, I have another diameter. The diameter cuts this in half. So this is 180 degrees. This side's 180 degrees. So if I subtract the 96, what do I get? 84 degrees. So this arc is 84. But then what do I have to do? Divide by 2. So what's the answer? 42, because I have to divide this by 2 to get the inscribed angle. Make sense? Yes, no, maybe, yes. Okay, so over here, I know that I have a diameter here, right? I also know that this subtends this arc here. So if I find this arc, I just divide it by 2. If I find PQ, I divide it by 2, and that's this arc over this, that's this angle, the inscribed angle. Well, I know this side has to be 180 because Nasala knows that. What other information could I put on this picture? Remember, you always mark what you know so you can find what you don't know.
G and R, or Q and R, sorry, is 108.
And how did you know that?
Because that angle's 54.
Right. Here's another inscribed angle right here. And it subtends, or like I like to say, cuts this arc. So if I double 54, it gives me this is 108. So what am I going to do with 180 and 108? I subtract, and I get 72, and then what do? Divide by 2, and that gives me 36 degrees. So this is 36 degrees. And now we're up to what we learned yesterday. We learned 3 formulas yesterday. We learned when the vertex of the secant or tangent or chord lines are on the outside, you multiply by half, right? And then you subtract the 2 arcs of the circle. If it's on the inside, you add those arcs, divide by 2. Remember yesterday? And then if it's on the circle, we just divide by 2. So this formula to find angle PQR, angle PQR is going to equal 1/2, and you have to subtract these 2, right? So 205 minus 85. So what is 205 minus 85? 120, and I need to multiply this by a half. And so angle P, the measure of angle PQR then is 60 degrees. And since you can use your notes, all you're doing is applying the formulas, right? Mm-hmm. Yeah, this one's the same formula, but I don't have any arcs on the outside. The only thing I know is that angle measure. I hate it when this pops up like that. Come on, go away. Go away. Okay. Oh, I hear it. Somebody remembered from yesterday. What am I going to mark the question mark as? X. What am I going to mark this other side as? 360 minus X. So now I'm going to apply the formula. So I have 66 degrees has to equal 1/2 of 360 minus X again. And I'm going to combine my like terms in the parentheses. How many minus X's do I have? Yep, so negative 2X is equal to 6. Oh, I forgot my 1/2. 66 degrees. What do I do to get rid of this half? Multiply both sides by 2. And so what's 66 times 2? 132. And then that just leaves us the 360 minus 2x. Because when I multiply 2 and multiply a half, that cancels out to a 1. So now you just use algebra. So I'm going to subtract 360. I should get a negative number because I'm going to be dividing by a negative number. What's 132 minus 360? 28. And then I'm going to divide by negative 2. And so what does X equal? Dun, dun, dun. Right? Okay, so now this one is on the circle, so it's just half of whatever this arc is, right? But if this side's 280, how am I going to find out what this arc is? from 360 because the whole circle is 360, right? So 360 minus 280 is 80. And now divide it by 2, and that will give you this angle here. So then that's 40 degrees. So angle DCB, B, not another D. The measure of. No, I'm just a math teacher, so I have to write it. But if you put 40 degrees, you're good. I just get happy. You get that far? Yay! Okay. So now I'm on the inside. What's the difference in the formula when I'm on the inside? You add the arcs. So I have 74 degrees as my answer. I still have that 1/2. And I'm going to call this an x because I don't like, so I'm going to add x plus 67. Okay, so how do I solve for x now? I'm going to multiply by 2. And that cancels out this half, right? And you get x plus 67 is equal to, what's 74 times 2? 148. And then you just subtract 67 on both sides. And that will give you your final answer. Well, I love that, Jay, because I want you to do well. However, there is one lesson that's going to be on the test that we're going to cover right now, and then I'll give you the review for your test. And this is easy. You all are going to like it because I know how much this class likes formulas. You don't like it when I say, oh, there's no steps. This is just more formulas. Oh, 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 oh. Okay. Oh, oh, oh. You're welcome. Well, it's really important for you to know. So. And really, we only have this lesson, and then I'm going to give you the review for the test tomorrow. Okay. Okay. So we know that if this is 112, this is 112 because they're central angles, right? That's something we covered in the do now. It's on. And I also know, let me go ahead and erase this one. The only thing I don't like about Cami is it keeps everything. I'm always erasing it. That if I have a circle that I could add arcs together if need be. So this one wants FHJ. So because it's a major arc, FHJ, that means I'm going FHJ. I'm going around this way. Do you all agree with that? Because it's the major arc because it's 3 letters. Because if I just went from F to, and you have to go in order, by the way. See how it went F, then H, then J? I'm not going to go F, J, H because that's not the order they gave it to me. They gave it to me first F, then H, then J. Okay, so it's basically the whole circle except for the 71 degrees. Do you all agree with that? So if I take 360 and subtract 71, that would give me this whole thing. Now I could just add all the pieces together too. It's up to you. I'd rather just do one thing. So that would be 9, 8, 289. So this would be 289 degrees. Or you could add in 49, 155, 45, and 40. That should also give you 289. Can I move on? Okay. So, oh, I don't want to use the dictionary. Okay, so over here we did these type of it says to solve for x, you wouldn't even need this 70. It should be, you just set it equal to 180 because this side here is a diameter, and we've done those. So I'm gonna skip these because we were doing these on our do now. Yes. Yeah, it wouldn't matter because it wouldn't be true. I'm glad you asked that question. So here's the diameter, right? So this side's 180 and this side's 180. You wouldn't add the 70 to it because this is where you're cutting it in half. So to set this one would just be 29x plus 60 has to equal 180. Okay? And this should be review. That's why I'm skipping through this because I noticed I want to get to arc length. So I'm skipping through the review since we reviewed in our do now. We are on the second page. The circumference formula for a circle could be written as 2 pi r or pi times diameter because 2 times radius is the diameter, correct? Okay, so either one of these could be used for the circumference, right? So the formula for arc length is a fraction of the circumference formula. If 2 pi r is your circumference and I have a central angle because I am only wanting part of the circumference, I am going to multiply the circumference by a fraction. That fraction is going to be the central angle over 360 degrees. Because what's the total circle? 360. And the central angle is representing the part that they're talking about of the arc length. So let's try doing a problem because sometimes if I do an example with real numbers, it makes more sense. So here we know from what I just said that if I take 2 times pi times radius and multiply that by the degree, remember we talked about degrees sometimes being called theta, and then put it over 360, this will give us this length here. And notice that it's in meters, right? So, what is the radius? 15. What is the central angle that they're calling theta? That is the central angle to this arc. 150. Okay, what do you need, Troy? It's just the angle, the central angle measured of the arc that you are talking about. Then you can't calculate it. You'll always be given the central angle because it's part of the circle, and I need to know how much a part of the circle. So to calculate this, then you would just substitute in your numbers. So 2 times pi times 15, and then you'd have 150 over 360. And I just have you round. I'm not having you reduce fractions. You'll find we don't do a whole lot of fractions in our, so it gets annoying, which is hard for you because when you get to quadratic formulas, they're not, which is a fraction. They reduce fractions a lot of times, but sometimes I just show them how to do it on a calculator. just because of the time frame. So 2 times pi times 15. Now I'm going to put in the fraction, which is 150 over 360. No, no square at all. We will be squaring because we're going to be talking about areas in a minute here. So this would be 39.3 meters. So if you think about arc length and pizza, arc length is going to be the crust of your pizza on the outside. So if you have a slice of pizza, right, the arc length of that crust would be, that crust piece would be your arc length. Now, the area would be the whole pizza slice. So let's try this one again. Pretend like you didn't see this. No, you didn't. You saw it disappear. That's right. Okay. So what's my radius? 15. What's theta or the central angle? 60. Now just use your formula. 2 times pi times 15 times 60 over 360. And then use your handy dandy calculator and give me an answer. Did anybody else get that? What was it? 15.7, and that would be miles. That'd be an awful big circle if it's in miles. I don't know why they use such big units because it doesn't really make sense. Can I go on? Okay. Did they give you access to CUDA software? Oh, good, good. Because you need that. Okay, so over here, just the same thing. It's not that hard, is it? What's R? What's my central angle? What's theta? 270. So now it's just 2 times pi times 16 times 270 divided by 360. Someone else gets 75.4? Again, this is kilometers. Big, humongous circle. Maybe those are the big fields that they're doing all the weird circles in the news a long time ago. Okay, can I move on? Okay. Now we're gonna do area. Now we have square units, Troy, because the area of a square is pi r squared, right? And we are finding a portion of the total area. So you would just have that degree again over 360. It's theta. Just change this to theta again. I think I got this off of 2 different Google slides somewhere. Or okay, so when we're talking about area, you are talking about like your whole pizza. So like I shaded this in, but now I can't see what the degree was, because we're talking about the whole thing, like the whole slice of pizza, not just the crust. So now it's going to be pi r squared with theta over 360. And you could put this in the front or the back because it's multiplication, the order does not matter. So what's r? 14. What's theta, or the central angle? 90. So now it's going to be pi times 14 squared times 90 over 360. 1, 5, and that would be feet squared. Yes, very good, because it's area. You try the next one. I'm going to not put that up there until you all try the next one, because I know the answers on the next one. So everybody try doing the next one on their own. If you need help, I can help you. Once you find your answer, check with your neighbor and make sure everybody at the table gets the same answer. So where did you teach before? Where? Okay.
Southeast, west, yeah, definitely southwest Indian, for 7 years. And so
That's why I'm an adult. Which one did you? Okay, I did Insight for a year, which is kind of with that.
Yeah.
But I was there right when they started closing some of them, and then some of them had to be like,
Because it was sketchy and irresponsible, yeah.
Yeah.
Ours was not one of those back then, but it's been like years ago. So that side of it's all about the money, while all the people who work there are all about the students, and that doesn't jive very well. So like I was our department chair, because I was also our math specialist, so like I coached all of our math teachers K through 12.
and they do a lot of coaching online. That's
Yeah,
like,
it was a lot, and I just couldn't keep up. Admin and all this stuff, and meetings, and they're like, well, you're running curriculum, and I said, you cannot teach mathematically.
mm-hmm.
Where, like, it has to be specific, and they coordinate things, or 40 points extra, and I was like, I mean, that's just literally wrong. And I was like, man, you have to be consistent, like, I kind of did the geometry curriculum until they first tried to push it out, and they ended up moved to really.
Is this the answer you got? Okay. So I'm gonna go ahead and let. That's not what you got. So we do round it. Yeah. But okay, so if you have 176.97 and you're rounding to the nearest tenth, you have to bump this up. So if you bump this up, you have to bump up the other one. Rounding is always an issue here. I don't know. I keep saying it needs to be taught in that math foundations class, but they never put it in. Yes, rounding is an issue. Okay, so I'm going to give you your break a little bit early. Go ahead and be back by 10:30, and then I'm going to give you 2 packets. I'm going to give you the practice to this and then the review for tomorrow. I heard you had pneumonia. He left. He's like, I'm not talking to you. I just wanted to give you a high five. Okay, so